Good morning. It's still morning. Border. All right, so this is a somewhat short talk. I think I have you guys for like 40-ish minutes. I'll talk for about 20, and then we open up for questions. From past experience, the questions tend to be the better part of it. You guys have great questions, so get them all ready. Okay, this is a talk called Differentiating by Data Science. And by differentiation, I mean in the competitive sense. So in nature, the competition for resources is fierce. As a result, species have created a lot of different ways to differentiate themselves. This scene here is an example. These are all herbivores, and each has found its differentiation. The giraffes, of course, specialize up on the high-end foliage, and zebras specialize at the mid-range, taller grasses and bushes. And then wildebeest, they focus on the low end, shorter grasses, shrubbery. Of course, speed is another form of differentiation. The cheetah competes with lions for resources. It's not as strong as a lion, but it can run faster, and that gives it an advantage. And identity is another form of differentiation, in this case, color. Poisonous creatures tend to be brightly colored. It's a form of branding, suggesting to potential predators that it's dangerous. And this is a coral snake. It is indeed poisonous. And by having this brand identity, it kind of has an advantage. It gets left alone a little bit more often. So what about differentiation in business? Well, as in nature, differentiation can provide a competitive advantage. However, in nature, differentiation is merely a result. Evolution has no plans for this. It's just a consequence. But in business, differentiation absolutely needs to be part of very conscious and very deliberate strategy. And all successful businesses differentiate themselves in some way. Recall those herbivores that differentiate themselves through vertical specialization? These department stores use a similar strategy. You got, well, here vertical refers to the quality and prices of their goods and services. You got Saks that has an advantage and focuses on the high end, Macy's on the mid-range, Walmart on the low end. And like the cheetah, speed is a form of differentiation. Amazon, through its fast shipping, has an advantage, especially for those deliveries that need to be delivered very quickly. And identity is another form of differentiation, in this case, branding, right? This pattern by Louis Vuitton may not be as brightly colored as that coral snake, but it is equally identifiable. And because of that brand identity, it has an advantage. People will pay 10 times more for a bag like this. All successful businesses differentiate themselves in some way, one or more of these things, that allows it to command superior returns that are sustainable. And one relatively new way to differentiate is through data science. Changes to technology have made new data available, and the company that better leverages that data is going to have an advantage. And now I happen to work for a company that is using data science as a primary means of differentiation. By show of hands, how many have heard of Stitch Fix? Almost ubiquitous. Okay, good. I have to remind myself, we're no longer this cute little startup. We went public last November, so we're now, it's a great way to get your name out there is to get some brand equity by going public. So if you're not familiar with Stitch Fix, it's clothes, men's and women's apparel. It's the same business model that has existed for hundreds of years, right? We buy clothes at wholesale and we sell them at retail. The difference is called margin. Same exact business model. But of course, the customer experience is a little different. At Stitch Fix, there's no shopping. The service picks out the clothes for you using a combination of algorithms and expert human judgment. So it's a different experience, but you could argue we still compete with other retailers, which we do. And we knew this from the beginning, and we had to set up the company appropriately. How are we going to differentiate? What's our strategy? And we chose very intentionally. We said, well, the traditional barriers to competition for retail are things like price. And we're not going to differentiate on price. We are not the low price leader. That's not what we're trying to become. We do no sales, no discounts, no markdowns, no promotions. We're a full price model. So price is not our thing. And fast shipping, we're not fast like Amazon. They're looking at like a week to get your shipment from Stitch Fix. We don't do same day or even next day delivery. That's not our thing. We're not fast. And branding. We have a fine brand, but nobody's going to pay anything extra because it's coming from Stitch Fix. That's, again, not our positioning. So we said we're not going to have those traditional barriers to competition. Well, what are we going to have? We said data science. We're going to do this better than anyone in the world because our business model is going to endow us with rich data, right? By taking away the customer's ability to pick out their own clothes, they tell us a lot more about themselves because they know it helps us to help them. And so this data enables a ton of capabilities. Things like this stuff. Now, most people, there it is. Most people think of Stitch Fix's data science team as, oh, you guys do the recommendation system, and that's true. But we have over 85 algorithm developers, and 5 work on the recommendation system. The other 80 are doing things like this. Inventory management algorithms, buying algorithms, planning algorithms. We even have algorithms that are designing some of the clothes now. We have algorithms in every function of the company. Each one gives us a little advantage, allows us to command superior returns that are sustainable. By the way, this whole thing is a plug for the algorithms tour. You can go to that URL and take a look. It's all just a recruiting thing to find more data scientists. But it is very nice. Visualization that's interactive and stuff. You can scroll through 10 of these algorithms are up on that tour. All right, so if you're going to do this, if you're going to differentiate by data science, it cannot be business as usual. You can't take the same old people and processes and org structures and expect it all to work out. You're going to have to do things different. So specifically, you have to change the role that data science plays in the organization, and you're going to have to create an environment in which it can thrive. So let's talk about the role first. So in most companies, the role of data science is merely supportive. It does enable efficiencies, but it's in support of some other department that is ultimately responsible for the impact. But if you're going to differentiate by data science, you're going to have to give them more accountability and more ownership. Specifically, I like to see these 2 elements of the role, that data science participates in the framing of problems and they participate in the conception of ideas. So framing, why is this important? Because you don't want to limit your data scientists to making only incremental improvements. Let me explain this. I'm going to borrow from nature to illustrate this point. This is the African giraffe. Of course, its differentiation is that long neck that gives it an advantage for going after that high-end foliage. It's graceful, it's elegant, and so appropriately designed. Or is it? Let's take a look under the hood at the anatomy of the giraffe. Okay, we see some cogent design here. We see an enlarged heart and arteries for pumping blood all the way up the long neck. But what's this? The laryngeal nerve. Its function is for sound. It merely needed to connect the brain to the voice box. It could have been contained up there in the head, but instead it takes that long detour all the way down and back up. What happened here is the initial framing was off. We used a mammalian blueprint. All mammals have the nerve on the wrong side of the aorta, including us. We just have short necks, it doesn't matter much. But as the giraffe, see it started from an ancestor that had a short neck, and as it found its differentiation, the neck elongated after successive generations, and that forced that nerve to have to get longer and longer and longer because it was stuck. It had a constraint there. You have to stay on that side of the aorta, so it had to get long. Now, as a consequence, that nerve got less and less effective. Giraffes don't make much sound. When was the last time you were at the zoo and you heard a kid imitating a giraffe? They don't make noises. It's like a moaning sound at best. Now, that's not optimal. And unfortunately, something like that can't be fixed through evolution. Evolution only honors incremental improvements, incremental changes. There's no mutation that's going to flip that nerve onto the other side of the aorta. You're stuck with it. The consequence is giraffes won't be able to make much sound. Now, in businesses, things can be more consequential. Oh, sorry. This is the whole point of the slide. Framing sets the course of the initial design and future evolution. So you got to get this framing right because it's going to impact you down the road. Once framed, typically only incremental changes are possible. Again, for the giraffe, it means it's stuck without the ability to make much sound. Businesses, things can be consequential as well. We develop our own versions of laryngeal nerves. Things that are constraining, yet hard to change. They're even hard to see sometimes. For example, we often tell our data science department to go optimize some metric. Get us to the top of that curve, we tell them. But we also subject them to constraints, sometimes unconsciously. We tell them, yeah, you can optimize, but don't do anything else differently from how it's been done in the past. Sometimes we don't say that explicitly because we're not even aware of our own assumptions. That is, constraints are invisible to us. We don't see them because we use an old and familiar blueprint when we design the service or feature, whatever it is you're doing. But the constraints are there, and they are constraining. And sometimes, let's see if this laser pointer works. No, let me go back. So the constraints are there, they just weren't visible before until you look at it from another lens. And here, you can see what we thought was optimal is not optimal at all. We could have been up there. So instead, we're stuck, like a laryngeal nerve stuck, operating in that plane, making only incremental improvements when we could have jumped up there. In other cases, the initial framing may prevent you from realizing that you're solving the wrong problem altogether. That is, you could be optimizing the wrong metric. It took a long time for the internet companies to realize that page views was a silly thing to optimize for. And again, like a laryngeal nerve, you may be stuck optimizing on that black line, making only incremental changes, when you could be up there on that blue one. So instead of asking a data scientist to optimize something, ask them to frame the problem, including objective function and constraints. Proper framing can enable incremental gains as well as the step function ones. Okay, that brings me over to conception of ideas. Again, I'm going to borrow from nature again to illustrate this point. There is a lot of things out there in data science that are hard to conceive of, much like there's some things that Mother Nature does that's hard to conceive of. This is a bucket orchid. Like all flowers, to reproduce, it has to have its pollen distributed. Now, these orchids have developed a very clever mechanism. What they do is they emit a nice scent that attracts a bee to come and land there on the edge of the orchid. Now, the edge of this orchid, or the bucket there, is made to be intentionally slippery. And that induces a fall into the bucket, which is conveniently filled with a liquid. Gets the bee's wings all wet, and it can't actually fly out with wet wings. And so it's kind of stuck in there. But the orchid conveniently provides a trap door at the other edge, one that could be crawled out instead of having to fly out. And the bee eventually will find it and crawl up to it. And as it passes through this little trap door, first the flower dries the bee's wings for it. But while it's doing so, it also affixes this pollen sac to its back. Right? There's a little pollen applicator at the top of this trap door, and it gets attached to the top of the bee. And then it is now free with its wings dried. It can fly off and distribute the pollen on behalf of the flower. That's amazing. It's brilliant and effective. And I would have never thought of that. I wouldn't have thought something like that was possible. This is real, by the way. You can watch there's a great YouTube video on it. Lots of interesting things that orchids have done. Anyways, they're very effective strategies that I could not have conceived of. I wouldn't have thought something like that was even possible in the world of flowers. And much in the same way, there's a lot of business applications that are hard to conceive of, unless you're a data scientist. These are things like using computational linguistics on the reviews that customers write to spatially represent your products. And this has applications, of course, in recommender systems, but also in inventory buying. Or there's the use of computer vision to turn pins on social media into a source of structured data. And again, this has application in inventory procurement as well as customer acquisition. Or there's the use of genetic algorithms to design new clothing by recombining elements from existing styles. These are all incredibly valuable applications, yet no one was asking for them. They didn't know it was possible. These were all conceived by data scientists. And we should expect that. We should expect the data scientists to not just frame a problem when asked, but to also conceive of the ideas that are not asked for. So that's the role of data science. That's the one they have to play if you're going to differentiate by data science. Now, in addition to providing the right role, you also have to provide the right environment so it can thrive. In terms of org structure, If you're differentiating by data science, then you should reflect it in the org. Data science should be a top-level department reporting to the CEO. This is more than symbolic. Data science has its own skills and ethos and tooling. It can't thrive if it's buried under that of another department, right? It really needs to have its own thing, its own way of working and so forth, so it can really thrive. Of course, having a top-level department also provides a seat at the executive table for high-level strategy. And of course, providing executive-level roles provides for a better career opportunity. Most companies, data science caps out at, say, a director level. But by providing these executive-level roles, you can enable a full career. Now, this brings us to the individual roles for data scientists. Should you prefer a highly specialized data scientist that does one thing really well, or do you get the more jack-of-all-trades generalist? Well, it really is going to depend on the type of environment you have at your company. Again, I'll use this example from nature to explain. That's a sickle-bill hummingbird. And of course, it's very specialized to that particular flower. The two have co-evolved. Now, there's other birds that also feed on the nectar of this flower, but they have different shaped beaks. They're going to be less efficient at it. But those same birds feed on a broader range of flowers. Now, which strategy is better is going to depend on how dynamic this environment is. If that flower can be relied upon to be available, then this specialist is going to thrive. But if something happens to that flower, meaning the environment is volatile, then the specialist is going to suffer. The point is this, is that specialists are far more sensitive to change. In a dynamic environment, prefer generalists. Okay? Now, how does this pertain to data science? Well, there's a lot of functions that data scientists perform, things like feature engineering, modeling and model training, building data pipelines, implementing your algorithms, building and integrating with APIs. Sometimes it requires you to develop an app, and measurement, A/B testing, and other forms. These are all functions that data scientists do. And it's very tempting to staff each of these with specialists, one person per box, right? I think we're tempted by this because we all know that there's huge efficiencies in the division of labor, at least in assembly lines, right? We all know Henry Ford's story, and this feels sort of like an assembly line because data kind of propagates left to right. And so we think, oh, well, gosh, if we specialize and get different people to do each thing, we'll be more effective. And that may be true for assembly lines, but data products are different. They benefit from iteration and change. That's the main thing, is assembly lines are built to be deliberately rigid because you can be very precise on your requirements down to the millimeter of precision. But for data products, you really don't know what you're building. You need to iterate through this. And so therefore, you want to embrace change. So while the flow of data may be left to right, the flow of development is anything but linear. It looks more like this, where you have to iterate and jump through these things. So you might find in your final phase, the measurement, you're A/B testing something, and you find some goofy result that causes you to go all the way back to feature engineering and redo things, and you jump through the hoops again. And that's a good thing. You just learned something, and now you want to get it back into the system as fast as you can. That's how you evolve the system. And so you want to be very fluid across these things. But iteration requires fluidity. If each of these are staffed with different people, you're going to have a coordination nightmare and lots of wait time. Wait time is when you're just waiting on the person to fix or adjust whatever you need done. And that's going to impede your evolution. So for nascent initiatives, things that you're still figuring things out for, prefer a generalist, a full stack data scientist, one data scientist that can do all these functions. They are out there. They're not unicorns. They exist. If you have one person that can jump in and do whatever needs to be done, you avoid the coordination cost and wait times completely. And this accelerates your evolution. You can learn much faster. Now, as things subside, it usually takes 18 months to 2 years to subside, where you stop, all that iteration slows down, you're no longer benefiting from as much change. Then you can specialize. You have a much more stable environment, and you can start carving up the workload a little bit. You have ETL specialists and modelers, et cetera. But wait until that moment when you hit a stability point. Okay, finally, this brings us to resources, by which I really mean talent. If you're differentiating by data science, insist on top talent. This is because there is a wide range of the skills of a data science is highly variable. You got huge amounts of, there's a wide distribution in skills, right? You got some people who can do a lot, other people can't do much at all, and you really want to insist on the top talent. Here's a good way to look at it. I can make a plot of talent, right, as measured by output or their contributions, and on this axis I'll put the number of individuals that achieve that level of talent. And you might get something like this. This is we have relatively few people that have low amounts of talent and few that have high amounts of talent, but and a lot in the middle. It's kind of bell-shaped curve or Gaussian. Right? Now, this is what you get for non-creative fields. This is not yet data science. This is non-creative. By non-creative, I mean things that are bounded by your physical abilities. So you should be thinking about bricklaying, right? A bricklayer only has two hands, and therefore they can't differentiate. They can't pull away from the pack very much. You might get something like this, where the best bricklayers are, say, 20% better than the average. I also include sports in this category of non-creative fields. You know, Steph Curry, as amazing as he is at shooting the three ball, he's about 20% better than average. That's it. He's limited. He's only got his eyes and his muscles and stuff and his reflexes. He can't pull away from the pack too much. You might look to another sport of Usain Bolt, right? He's going to even be a tighter distribution on runners, right? They're not going to spread themselves out too much because they're limited, constrained by physical abilities. However, for creative fields, which I very much think data science is a part of, you get a different distribution. No longer are you constrained by physical abilities. It's limited only to your brain. And you get a different distribution. You get this fat right tail. Now, with this type of distribution, it's possible for the best ones to be 10 times better than average. And I mean no hyperbole here. I have worked with individuals that are more productive, more innovative than even a team of 10 average data scientists. And you really want to get those ones out there. Now they're not unicorns. They are out there, but they're rare. It is hard to find, and you want to maximize your density at the right end of this distribution. Okay, as a closing thought before we go to questions, I used a lot of examples from nature where there was implied a stasis has been reached, that each species differentiated themselves and now dominates their niche. Well, that's true. I presented it that way, but the truth is nature is anything but static. There are always changes to the environment happening. They happen in geological time, so it's a little slower, hard for us to see. These are things like land masses separating and new mountain ranges emerging, climates changing. Okay, we can probably observe this one in our lifetimes, but the others are a little slower. And this is resulting in new adaptations. The species that once were the fittest no longer are. They may find themselves dislodged from a niche. It also results in the emergence of new species popping up. Now, over here on the business side, we have the same thing happening. There are always changes to the environment happening. And these are technological changes, things like web, mobile, IoT, big data, AI, et cetera. And this is resulting in the exact same thing, new adaptations. The businesses that were once the fittest find that they no longer are, and also the emergence of new businesses altogether. So just bear in mind that technological change is much, much faster than geological change, and that it's the adaptable, and particularly the new, that are going to have the big advantage. That's all I got, and we'll go over to questions. Thank you.
So just in terms of evolution, and from the outside, all we see are your fashion endeavors. There are, to extend your analogy, there's a type of orchid that tries to look like a male bee to attract a female bee, except that bee hasn't existed for thousands of years. Now you work in fashion, where every 2 years, the cycle of sleeve length, the cycle of color could be completely different than before. How does a data science team on the fashion side deal with that problem, which is a little different than biology?
Yeah, things evolve quickly in the world of fashion. It does make you have to do different type of recommender systems. The canonical collaborative filtering, or people who bought this also bought that, it doesn't work so well with fashion, right? It works really well with books, music, video, things that are durable, right? You can buy books that were written hundreds of years ago. You can watch movies that were created 50 years ago, et cetera. But fashion, you can't find stuff. You can't buy it anymore unless you go to a thrift store, but you really can't find things that were even a year old. They're gone. They're no longer in style. So you're gonna have to use a different type of recommender system, which of course we do. We use a myriad of approaches, everything from mixed effects models to deep learning and other techniques. But you need to train them on recent data, right? You don't wanna go all the way back, or you can use hierarchical models to abstract higher level concepts from things that maybe are shared, like there's silhouettes that may still exist, but they're gonna be very different stylistically. And there may be preferences for silhouettes that you wanna borrow from and learn from it. So you do have to pay attention and constantly retrain. It makes things interesting on the inventory buying side, because whatever's in style today is probably not going to be in style 6 months or a year from now. And so you need to stay ahead of these trends or guess really well. We do divide up that work. We have algorithms that are buying the clothes, but they're buying clothes based on more recent history. We have humans that buy the clothes that have to think about 6 or 12 months out. Right? That's where the data is going to fail you. There isn't anything in your data that's really going to predict those trends. It predicts very recent trends, but not future trends. Right? These are more informed by ambient information, such as who wore what to the Oscars, or magazines on your coffee table, that kind of thing. And that's where humans thrive, is digesting ambient information, reading tea leaves, and that sort of thing. So it is a tricky one that you're going to have to rely on more than machine learning to do it.
A couple of questions. First one, what do you think was key to your success in hiring this top talent, especially when you hired the first few? Because generally talent attracts talent if you hire the first few, right? So that's first question. And second, when you hire these top talents, how do you pave the growth path for them so they remain successful, happy for the longest time?
Yeah, so let's see. Two-part question. The first one, you're absolutely right, is you want to get really good people from the beginning because they attract more really good people. And pay attention for diversity and stuff like that too, because your composition of your current team tends to perpetuate itself. So you ought to take care of these things right from the beginning. So in general, the way to attract talent, or at least for us, and we have a blog post on this topic, is really be aware of what your audience is looking for. So for a prospective data scientist, which everyone on my team has been a data scientist before, and we still are, and so we feel like we have a good judge of what people are going to look for, what drives job satisfaction. And so we look for three things. Number one is look for a company that where what you do is going to matter. So hence the talk, differentiating by data science, it's what we do. So if you're a data scientist at Stitch Fix, it's going to matter. If you went to, say, Louis Vuitton, remember the bag? It's not going to matter much. They probably have data scientists at Louis Vuitton, but it's fine-tuning, maybe operations, stuff like that. It's not going to change the stock price, right? So number one is go somewhere where you're incentivized to be the best in the world at what you do. And so at Stitch Fix, it would mean data science. If you were a product person, maybe Apple. If you're a marketer, maybe Nike, right? Regardless of what it is you do, find a company where that matters a lot. So for data science, go to a company like Stitch Fix. Number two is go somewhere with interesting data, because you're going to spend 8 hours a day doing something. It better be interesting, right? Of course, Stitch Fix has great data. If you're interested in cognitive psychology, it's fascinating stuff to find out what makes people buy things and how they trade off one preference for another. It's amazing. The data's super clean. Right now, contrast to I apologize if anybody's in ad tech, but it's a little messier data and less interesting. The phenomenon are less clearly explained, right? So I wouldn't care to work as much as ad tech. I'm sure they have some interesting problems. Anyway, so that's number two, go somewhere with interesting data. And number three, go somewhere with greenfield opportunities, right? You want to be the one to frame the problem. You want to get that low-hanging fruit, right? So if I were to be an engineer working on search at Google, that would be exciting, but it'd be far more exciting if I was the first person to do it, to be Brent or Page, whichever one wrote the paper, and framed the problem. I would not want to be the 10,000th and first. at Google because a lot of the low-hanging fruit's already done. You're going to have to prove your point it's better than the existing framing and all that kind of stuff. So the greenfield opportunities drives a lot of satisfaction that you get to be the first one to do these things, low-hanging fruit, et cetera. So those are three important things to look for, and that's how we often win on recruiting, is we offer those things, as well as a full-stack data scientist role for the right person. That is thrilling, that you're not dependent on somebody else, and the opportunity for impact, that you get to see the fruits of your victory. You can allocate yourself 100,000 clients or something into an A/B test cell and see what you can get out of your new algorithm, and that is thrilling. So, all right, we had a question somewhere over here. So the question was about describe the culture, how new models are identified. So it all starts with tinkering. We don't grant this 20% time like Google does. We thought about it in early days of Stitch Fix. I'm like, do we need to structure anything? We thought, they're going to do it anyways. In fact, I could be so explicit as to say, whatever you do, don't tinker on that thing. And they're still going to do it. People do it. They can't help but scratch that itch. They get curious. They tinker. They think of something like, I wonder if this is related to that. Oh my God, it is. And this isn't anything they're supposed to be working on. But they can't help themselves, and they tinker, and they come up with something. And again, the two properties that I find are help with innovation is, number one is low-cost exploration. That's what I just described. This isn't costing us as a company anything because these people do it on their own time. So they explore things. And the second property is evidence. They have evidence that what they're doing is on the right path, meaning they have data, things like AUC, right? They can measure the stuff, this is gonna help. And they know that it's gonna be valuable. Before they even get to the point where they're proposing it, they already know it's gonna work. They may have already A/B tested it and got their really result, and they said, at this point it becomes what we call a no-brainer. You mean you're gonna roll that thing out, it's already done, and it's gonna get us X amount of revenue or reduce cost or whatever. That's a no-brainer, we're doing it, all right? And so that's how we sort of motivate a lot of the innovation that happens. Low-cost exploration, evidence that they're on the right track. And they self-regulate, they may tinker on something, and then the evidence doesn't manifest. That's stupid, I'm gonna put that away, right? And so they monitors that way. So the question was, that describes how data scientists do it, but what about the rest of the company? Well, we do have, as a company value, we value innovation. It's stated as one of our 4 company values. So we do foster it across the company. I will say that data scientists have an advantage because of those 2 properties. That is not shared universally. If you're in engineering, oftentimes it is not low-cost exploration. You have to build something, right? And then to find out if it has any merit, any evidence, you actually have to launch it. And it's gonna be a tougher sell, right? Then you usually have to ask permission to take some time to build something, and then you still have no clue if it's on the right path until you actually try it. So it's tougher, and same thing with other departments like merchandising. They might have a wild idea for a new line of clothing. It's gonna be expensive. It's not low-cost exploration. You're gonna have to design it, and then you don't have any evidence until you try it. So it is a little harder, I grant you that. So data scientists, you all enjoy a wonderful domain where you have low-cost exploration and evidence. Okay, we'll go back there.
How do you convince CEOs and other executives that data science should be its own executive function with a seat at the table rather than like nestled under a CTO in the tech org?
Yeah, how do you convince it? Now, one clarification is this differentiating by data science isn't for everyone, only if your business model supports it. Louis Vuitton, don't differentiate by data science. No need to have a data scientist reporting to the CEO. I just don't think it's that valuable to the company. So you have to really know your company's positioning and where they drive differentiation, where they are, where they can command superior returns that are sustainable. And so once you have identified that, then you can have that conversation with the CEO. And usually it's fairly compelling. You can, again, we have evidence to show. Maybe if you haven't done anything yet, you'd have to be persuasive. But there's a lot of evidence that we know pretty precisely. Most things can be A/B tested, and you can show, look at the valuation we're driving. Other things can't be as easily A/B tested, but you have other ways at demonstrating the evidence. And so it usually becomes an empirical discussion based on results and outcomes, which is great because like many data scientists, I don't have a lot of confidence. I need to stand on evidence before I can be persuasive. And so you end up doing the right thing without having to really persuade unduly. Over here.
So one way in which data scientists differ from giraffes that I can think of is that giraffes all come from the same place, which is other giraffes, whereas data scientists have these really, really wide-ranging backgrounds, and especially because it's kind of an exploding field, a lot of people are coming from elsewhere. What do you see as the kind of future landscape of training in data science and continuing to train as you work as a data scientist to remain in that top talent echelon?
Yeah, so I think you're generally asking about what are the skills of a data scientist, what are the valuable skills? Yeah, most of they're pretty diverse in terms of academic background. They're mostly PhDs, but it's from astrophysics to neuroscience to psychology. I guess the only thing they share is a quantitative focus. And to be honest, when we interview, those are all just check boxes, right? We do scrutinize for fundamentals. Like you need to be able to derive some of the linear algebra beneath the algorithms, not just execute the algorithms. We need to know that you know what you're doing and you can control for things and so forth. So we are weenies on that part, but they're just check boxes. We're just saying good, 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 good. They can do all these things. Now, once you've pushed that stuff aside, let's focus on things like storytelling, communication, visualization, passion is probably the biggest one. Right? We need people to carry their jobs through their passion. The reason is I can't tell them what to do. And then people think I'm this brilliant leader. Wow, he doesn't tell me what to do. He uses more Socratic methods. And the truth is, there's no brilliance there. The truth is, I don't know. I don't know. I can't tell you what to do. All I know is there's something in there, and you're going to have to find it. And so you can't write requirements for them. You're going to have to rely on them to do it. Now, the reason passion matters so much is that anybody can execute through requirements and kind of say, oh, I'm good, I'm done. But the person that's really going to find something is going to be the passionate person, because it's easy to stop quicker. It's easy to say, well, no, here's your results, that's it, that's all I'm doing. But the person with passion is the one that voluntarily will stay up at night, that voluntarily sets their alarm early just so they can get up and check on those A/B test results, right? And that's what you need to drive a lot of these forwards, because I'm not going to be the one to tell them how to do this because I don't know how. And so we look for the passion and curiosity and all those traits. Of course, you need the other stuff, but it's just a checkbox. And then you differentiate on that stuff. All right, there was some question out in this general area here. Here's a microphone coming.
Yeah, I wanted to ask about your transition to menswear. You know, you have a data science team and all these models that are trained on female preferences and women's fashion, and presumably not a lot of data about men's clothing. So I'm just kind of curious, how did you guys go into that so you had a successful launch of men's clothing products and maybe make use of the algorithms?
Yeah. So the nice thing is we do have a great data platform, so that you don't have to rebuild all this stuff when we launch a new business line. We start with women's, and then we open up men's. And a lot of this stuff doesn't need to be recreated. Now, you do have to retrain models, but it's a matter of opening those spigots and letting the data start to flow through. And it is a cold start problem, right? You have no data, so how are you supposed to do this? And the nice thing is the hierarchical models that we use, you get to learn pretty quickly, borrow from other clients like them, for example, and other pieces of merchandise like them. We learn a lot faster on pieces of merchandise than we do clients. Clients engage with us once a month or so. And so you learn kind of slowly. Clothes, though, you can buy 1,000 units of something and start sending them out to intentionally varied samples of people so you can learn quicker, right? So once you get the learnings on the clothes, you can even apply it to a client that you don't know very well, because you learned from the clients you exposed it to. And so you get to borrow those learnings. And so you actually can cold start pretty quickly, and especially given the richness of our client data, right? So before you can ever get a shipment from Stitch Fix, you have to fill out a questionnaire of about 80 questions, right? So we know a lot about the customer before we've even engaged with them. And so it does help with this cold start problem and getting it up really quickly. But the infrastructure allows us to not have to recreate the wheel. The whole same exact algorithms can work. They need to be retrained, but they work. And so that was very nice property. So the question was, what are you A/B testing for, or how do you figure that out? Or said another way, how do you figure out what the objective function is? And it is one of the most important things a company can do. And of course, there may be different ones for different departments, but it is a surprisingly hard thing to figure out, because you think you know it, and maybe a little later you find out there's ugly side effects of that particular objective function, so you have to switch to another one. We're a little bit newer on the marketing side of things. We grew largely through word of mouth, and only in the last couple of years did we start to actually do marketing stuff, paid acquisition, and we're still learning there. This is not like an e-commerce company where success is buying something, right? That's not our success criteria. We need to make sure this is a great customer relationship, right? And so we have to change that, right? Our performance marketers, they originally were trained on, just get people in to get them to buy something. I'm like, no, that's not what we need. We actually need them to have a great experience and a long relationship with us. And so you have to work on these things. They have to iterate, right? Hence evolution, and hence you want things fluid and nimble. You don't want to harden things at the beginning. Leave yourself room to iterate through. That's probably the best way I can answer that, is be flexible.
First of all, thanks for the presentation. Sure. I think I have a lot of stories for my 5-year-old today. I can talk about all what I know about giraffes and whatnot. In terms of you have a lot of personal data and you do a lot of personalization. I wanted to pick your thoughts on, the sensitivity of what you expose to customer and the way the data field is growing in terms of, we have such a clash with ad tech and whatnot. How do you foresee retail? Retail has been so far been, Spotify because we don't see that kind of stories in media. How do you see, where that balance of personalization lies for companies like Stitch Fix or any other retailers? And what do you see from an ethical point where a data scientist would lie on what you can do and what you cannot do with personalized data?
Yes, so you're talking about privacy, which is very important. So our customers are trusting us with their data, right? They're telling us a lot about themselves because they know it helps us help them. And so we have an obligation to protect that data. And you all work at companies, you have an obligation to protect this data. This is not just, immaterial information. This is useful stuff that people don't want getting out. So you have to commit to that, right? You have to put on multi-layer security, which we've done all that. The other smart thing you can do is partition your analytics systems from the transaction processing. Much of the personally identifiable information, name and address and stuff, they don't have much analytic value anyways, so don't let it in. Strip them out. Anonymize your customers, and then you'll sleep better at night as the owner of the analytics environment, right? So in all of our algorithm systems, we do not allow PII in there, personally identifiable information. It doesn't have much value, and it allows us to sleep better at night by stripping it out before it gets in there. And so we know that this is a customer record, we just don't know who it is. Right? And we know that they bought these things, and they know that they have preferences for X and Y. We just don't know who it is. And that's not important. We don't need to know who it is until we're serving recommendations, which can be de-anonymized at runtime. And so one thing is, keep your PII contained in one system. Don't let it proliferate. The other thing is, don't store credit cards if you can. We don't store credit cards. It's nice to have that separated. So. That would probably be the most sensitive data we had, and we don't store it at all. We partner with somebody else to do it. But treat this stuff seriously, right? I think for years we've been lackadaisical on it, and I think now companies are finally taking it seriously. We've done it from the beginning because I've learned from past companies not to make those mistakes, separate the stuff, strip it out, anonymize it early. And actually, GDPR stuff for Europe, that's a lot of nice properties, and some of those things should be adopted here in the U.S., even though it's not required. But the right to be forgotten, et cetera. I think those are all very nice properties that we should offer our consumers. Good question. All right, last question, I think.
So I've been a customer for several years. I'm wearing a Stitch Fix shirt right now. And one thing, I have a background in algorithms. I'm a data scientist, but you give me this personal stylist, and I found that I had to start training myself to be more brutal in my reviews and be like, okay, I'm pretty sure they're not actually reviewing my stylist too harshly if I don't like the thing the algorithm picked for me. So, what do you do? Do you have any concept of how you might be able to communicate, or what effect this might have on your customers, that reviewing a person who wrote me this nice paragraph is very different from reviewing an algorithm that's going to send me a box in a couple months?
It's true. It's a great point. So we considered an algorithm composed of distributed resources. There's machines and humans, both have material contributions towards the algorithm. So we do think of them as part of it. And they do different functions, things that machines can't do, such as fostering relationships, curating, and improvising, right? These are all things that are in the purview of humans. So they do those things. And to answer your question more directly, they're reviewed in a very different way. Some of our most sophisticated statistics are actually focused on stylist measurement. We have to control for all kinds of things. We have some clients that you can send them anything and they're going to be thrilled. Other clients that are very challenging, maybe a woman, say 6'2", with eclectic and eccentric taste, that's going to be harder to satisfy, right? So we know this stuff. We know the hardness of the client, we know the difficulty of the conditions of merchandise, and we do not penalize the stylist for that, right? We judge them on a few other metrics. They are not commissioned, right? So this is important. Do not commission your folks because you don't want to soil the incentive structure. And so they are reviewed on things like empathy, how well they complied with the client's preferences, how well they match the tone of their note to the tone of the client's notes. This is how they get reviewed. And we know when things are, the inventory conditions do ebb and flow, we know how to control for all those factors, and we know how to control for a difficult client versus an easy client. So I think they do pretty well. All right, I think that's it. I see zeros on the clock here, so that means I got to get off. So thank you all.